All right, guys, so we're moving back into division. Before we can get to division with decimals, we have to make sure we review division with whole numbers. So I'm going to try and make the beginning of this quick because it's kind of really going back to the basics, and that is the meaning of division. It's super important to understand what we're doing, not just how to do it. So we know that we read sentences from left to right. Since this is a division number sentence, we are going to also kind of look at this number sentence from left to right, meaning this number all the way on the left is the amount of objects that we're starting with. So maybe we have 37 markers, and division means we're going to split those markers up evenly into groups. And in this case, we are going to split them up into groups that have 9 in each group. And so we want to figure out, well, how many groups can we make? Now, we may not be able to make even or equal groups of 9, so there may be some left over, and we know that that leftover is called a remainder. So here are my 37. I'm going to put 9 in each group, and since I did draw these X's in groups of 10, I know that that would be 9, so that's one group. This would be another group of 9 markers. This could be our third group of 9 markers. Let's see if I have enough for another group. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, yes, I do. So that is going to be my fourth group, but unfortunately, I don't have enough left to make 9 in the next group. So you can see that I'm able to make 4 whole groups of 9. So that's where that whole number comes from. But now I need to somehow show that there's that one left over. So that's what we call a remainder. So we would write 4 with a remainder of 1. Now that wasn't too hard to show as a picture, but there are times when the amount of objects that we're starting with, in this case, if I have 89 students, I don't want to draw 89 students. There has to be another way for me to do this other than drawing a picture. And so that's when we actually have to set up a division problem. And the first part of this lesson is something that I'm going to expect to see today, and that is when you set up the problem, I really want you to set yourself up for success. So let me show you what I mean by that. So first off, we don't set up a division problem with this division symbol. If we're doing addition, subtraction, or multiplication, we just rewrite that going with the columns. You know, if I have, I don't know, let's just say 47 times 3, if I'm going to set this problem up, I'm going to set up 47. I'm going to use that same multiplication symbol, and I'm going to put a 3 and an equal sign. That is how we do it for addition, subtraction, and multiplication, but not for division. We use a completely different symbol, and the symbol looks like this. So now we need to know where to put our numbers. The amount that we're starting with does not go on the left. It actually goes inside the house. And part of setting yourself up for success is giving yourself space and writing big enough. So I'm not going to put the 9 right here. I'm going to space the 9 out a little bit and move it over here. The number that we are dividing it by, that's going to go over here. So they kind of almost seem to switch places. Now, that's the basic setup. But there are 2 other things that I'm going to be looking that you're doing to help set yourself up for success. One is to add multiplication man. It's such a silly, easy thing, but it's going to help get our multiplication brain going because our division brain is not always as strong as our multiplication brain. Number 2 is a big one, and I made this sort of optional before. It's now going to be required as we're moving into decimals. It's called digit box, remainder box. What that means is for every digit in the amount we're starting with, so here we have an 8 and we have a 9, our answer, which goes up on the roof of the house, is going to have a digit for each one of those, for each one of those digits. So where I have a digit here, I am going to draw a box directly above it. And that box is a blank space for a digit. That'll be in my answer. Digit box. Now I never want to forget to give my remainder as part of the answer because it's part of the answer. So I'm going to have remainder box. So it would sound like this. Digit box, remainder box. So now each of these boxes can only fit a single digit. The highest digit there is a 9. So what can go in that box is a 0, a 1, a 2, a 3, a 4, 5, 6, 7, 8, or 9. If you think you're supposed to put a 2-digit number in there like 10 or 11 or 12, it means you made some ginormous mistake and you need to go back. So we'll have a digit here, and a remainder with a digit here. That's what our answer is going to be placed inside of. So this will be our quotient or our answer. Okay. Okay, so now that we know how to set ourselves up for success, we're going to do that along with solving the division problems. My goal here is to give you a really important suggestion that is not really a suggestion, it's a do it, because it's going to help you as we move into harder problems next. So first, let's go ahead and set our problem up. I don't want to draw 952 of anything, so I know I'm going to need to use my other division symbol. I'm going to put the amount that I'm starting with inside the box, and I am going to space these numbers out. I don't need to crowd. I can even stretch that division symbol. The amount of that I'm dividing by, I'm going to sit over here. So I know my answer is going to be on the roof, and so we are going to create a template for our answer. And first I'm going to put multiplication man here, and then I'm going to digit box. And again, the digit box creates a template for where my answer is going to be. So we have digit box right above it, digit box, and then of course remainder box. So right now I know my answer is going to have a digit here, a digit here, a digit here, and then a remainder with a digit here. It kind of helps guide my thinking along. Okay, so now we are going to go ahead and start solving it, and we're going to use multiplication man, and we're going to use our idea of a bow and arrow trying to hit a target. Now, because this is a 3-digit problem, I'm going to end up with 3 different targets. So I'm going to go ahead and circle my very first target. Now, I can't circle my second target or my third target because those will always change as the problem goes. So here we go. I am thinking 4 times what gets me closest to 9? Well, this is where I want you to do something to help yourself. Off to the side, I want you to set up a little multiplication chart for yourself. Now, I always want you to start with the middle digit. Middle digit is 5, and we should know our 5's facts really well. So we're trying to figure out 4 times what? Let's get 4 times 5 on the board. 4 times 5 is 20. So if my target is 20, I'm going to use the 5. Right now my target's 9. 9 is less than 20. I don't necessarily need to fill all of these in right now, but knowing that 4 times 5 is 20, I know that I should be guessing a number less than 5. Well, okay, 4 times 4, that's 16. That's still too high. I can never go past my target. 4 times 3 is 12. And if I want to write these down, that way I have them for later. 4 times 4 is 16. 4 times 3 is 12. That's still higher than my target. Let me go backwards. 4 times 2, that looks good. That's 8. So what that means is for this particular target, the closest I can get to the 9 is 8. And that's using the number 2. Now, this is my target. When I use the 2, 2 times 4 lands at 8, which I already did right over here. I don't have to do that work again. And now I need to figure out the difference. Here's where I was trying to land. Here's where I landed. Difference. Difference means subtraction. If you are strong with subtraction, then think subtraction. Not all of us are strong with subtraction. So another great strategy is to count up. Start where you landed, which is 8. Now count up from there till you hit the target. Well, starting at 8, one more already brings me to 9. So there's my difference. And to check, 1 plus 8 is definitely hitting my target of 9. Now, that's great. Do not erase this because I might use it later. That 4 isn't going anywhere. I'm going to keep using it over and over again. Now, the reason I could not circle my target of 5 ahead of time is because I didn't know what this number was going to be. This is my leftovers, but I'm not ready to put in my remainder yet. I'm still working through the problem. So what I'm going to do is actually bring that leftover up and combine it with the 10s I already have. So now I have a brand new target. It's not 5, it's 15. What's really, really nice is if you look over here, I don't have to actually do much math. I can see that 20 was too high, 16 is just too high. It looks like 12 is going to be the closest I can get to 15 without going over. So 12 is going to be the closest. How did I get that 12? Well, I know that 4 times, and you can see it over here, 3, that's why multiplication man is helpful, 4 times 3 got me to 12. And now I have to figure out how far away, what's the difference between my target and where I landed. Again, difference means subtraction, but if you're not strong with subtraction, let's count up. Starting at where we landed, starting at 12, 13, 14, 15. I counted 3 going up. Well, 3 plus 12 lands at that target. So again, I can't start my new target yet, and this is my leftovers, but I'm not ready for my remainder. I still have another digit in my answer. So I'm going to take that 3 and I'm going to throw it up here to create my new target. Now again, look over to where I already did my work. My new target's 32. The highest we've even thought about is going to 20. That's not quite close enough. So now I need to build my chart a little bit higher. So let's see, 4 times 6, it's getting closer, it's 24. 4 times 7, ooh, that's even closer, it's 28. Let me see if I can get closer. 4 times 8, that is 32 on the spot. So the closest I'm going to get is to do 4 times 8, which lands me exactly at 32. And we want to figure out the difference between our target and where we landed. Well, the difference is 0. I hit my target. And 0 plus 32 is 32. That's my leftovers. That's how many I couldn't use when I was dividing. And the only place for that to go now is my remainder. So my final answer is right up here. It includes my remainder. It is 238 with a remainder of 0. So I'm going to quickly go through this next one. It's going to be so much speedier. Okay. Going to have to rewrite my division symbol to look a little bit different. And I'm going to start by writing 6,809, spacing it out. And we're going to divide that by 8. Time to set myself up for success. Multiplication man and digit box, digit box, digit box, digit box, remainder box. I know that my answer will have a digit here, a digit here, a digit here, a digit here, and then a remainder here. I'm going to end up with 4 different targets, but I can only circle my first target to begin with. Before I start, I'm going to set up a little list of multiplication problems. My number I'm working with is 8, and I'm only going to do the middle one, 5. And I know 8 times 5 is 40. Now I'm going to build this list in different directions later on as we go through the problem, and I'm never going to erase it because I want to make sure I have it to use over and over again. Okay, 8 times what gets me closest to 6? Well, 40 is way too high. 6 is a pretty small target. I know that 8 times 1 is 8. And 8 is already passing my target. And the only number I can go less than 1, you got it, 0. So I know that the closest I'm going to get to hitting that target is using a 0, and 8 times 0 only landed me at 0. It wasn't very good. So the difference between where I started and where I landed is 6 away. I didn't get anywhere. 6 plus 0 is 6. The reason I could not circle that target ahead of time is because this leftover 6, I can't put that as my remainder. You can see I still have work to do. So that 6 is going to go here. Now this is why I love this little chart over here. My target is so much bigger than our first target. First target was 6, now we're at 68. I know that 8 times 5 is 40. I need to go much higher, in fact quite a bit higher. I know my 9s really well because I have fingers that are awesome. 8 times 9 is 72. Close, but too high. So 8 times 8, clap, clap, floor, 8 times 8 is 64. That's going to be it. So 8 times 8 is going to get me to 64. Again, the difference is subtraction. I can subtract or I can count up starting at 64, 65, 66, 67, 68. I am 4 away. And that makes sense because 4 plus 64 is 68. This is my leftover. I'm going to throw it up here and I get a new target of 40, which is, boom, right there. 8 times 5, we said, is 40 exactly. So I hit my target. I'm 0 away. That leftover is going to get thrown up here. And again, I've already done half the work. Look right here. I know 8 times 1 is going to land right at 8, which is only 1 away from my target. That 1 is my leftover amount, Please remember that your leftover must always be smaller than our divisor. Let's work on setting ourselves up for success.